Hello, mathematicians. It's Debbie, and today we get to delve into one of my favorite parts of the world of mathematics, and that is graphing. Graphing is super fun. We get to draw pictures. In this case, we really just get to draw lines, but it's still fun. There are 3 ways to graph a line. I am going to go through all 3 of them. Everybody has their favorite method. And some of the methods are more simple than others, and others are a little bit more efficient because they always work. I'll tell you what I mean in a moment. So let's talk about these 3 ways. I have an equation here. You can see my example. And I am going to start with these ways to graph a line. The first one is by intercepts. Intercepts means the x or the y-intercept. So the intercepts are a really interesting way to graph. The x-intercept occurs in any graph when the y variable is 0. So it means we have to plug a 0 in for the y. The y-intercept happens to occur when the x-coordinate is 0. So check out our equation. I'm going to try for the x-intercept first. So 2x minus 5y equals negative 15. But the x-intercept says, well, if you want to know where it crosses the x-axis, we don't want a y here. We want to put a 0 for y. And then we're going to solve this. So 2x minus 5 times 0 is 0. So basically, I get 2x equals negative 15. I'm going to divide both sides by 2. And that gives me my answer, which is x equals negative 15 halves. I'm going to make it a decimal because sometimes it works to do decimals. So negative 7.5. So our x-intercept is negative 7.50. And right away I think, maybe this wasn't the best choice, because that's kind of an awkward place, but we can still find it. If I want to graph the point negative 7.50, here's negative 1, negative 2, negative 3, negative 4, there's negative 5, negative 6, negative 7, and negative 8. Negative 7.5 is going to be halfway between right here. Negative 7.5, 0. That is the x-intercept. Now let's do the y-intercept. So to find the y-intercept, I'm going to do 2x minus 5y. I don't have room here. I'm going to move. You know what I might do is I'm just going to erase this. I'm just anticipating running out of a lot of room. So let's plug it in here. So 2x minus 5y equals negative 15. Notice that this equation is just like the equation above it in our example, except where there's an x, I left a little blanky blank. What am I going to put in the blanky blank? This 0 from here. And if I do that and solve, 2 times 0 is 0. So what I get is negative 5y equals negative 15. I'm going to divide both sides by negative 5. And by the way, if you need a lot of extra algebra practice, I've got lots of fun ways to practice. So ask me. I can help you with that. Y is 3. So I'm going to put that there. So when x is 0, y is 3. That point is 0, 3. 1, 2, 3. Remember, the first number is where I go to the right or to the left, and the second number is when I go up or down. So 0 to the right or left, and then 3 up or down. My line then, if I can do this, ooh, you never know. Sometimes this board is a little tricksy for me. Yep, as you can tell. Oh, no, don't move. Looks about like that. Give or take a couple millimeters. That's one way to graph the line. However, you might have a hard time with the homework because, well, graphing the point -7.5, 0, sometimes that's hard on our WAMAP, the online homework that we do. So we're going to try and find some other ways, okay? So the second way is by plugging in points. Let's do that. What I do when I plug points in is I make a handy dandy XY chart. And then I just plug in sometimes random points. I always plug in a 0 for X and a 0 for Y. You recognize those points as my X and Y intercepts. Sometimes I take what the coefficient of X is and plug it in for Y and try and figure out what X is. Sometimes I take the coefficient of Y and plug it in and see what happens there. So let's do that. So I've got 2x minus 5y equals -15. And I'm working on this one, which says, what's x when y is 2? So that gives me 2x minus 10 equals -15. Oh, that one's not going to work out very well for me because if you'll notice, if I add 10 to both sides, I get 2x equals -5. Yeah. And then x equals -5/2, which is -2.5. I don't love that point any more than I loved -7.50, but let's do it anyway. So if I go -1, -2.5, then I go up 2. Oh my gosh, look at that. Do I feel good about this answer right now? Yeah, you better believe I do. The next point is when x equals 5. So it's 2x minus 5y equals -15. And now I plug in this value for x. And remember, these are random values. I could have chosen other numbers, and I just keep choosing numbers until I get an integer. Right now, the only integer pair I have is 0, 3. That ain't good enough. So let's keep plotting away. Hopefully this one will work. Secret, I know it will. So 2 times 5 is 10 minus 5y equals -15. I'm going to subtract 10 from both sides. This goes away, and it leaves me with -5y equals -25. Divide both sides by -5, and I get y equals +5. A negative divided by a negative is positive. So I get 5, 5. Let's see if that works. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What? It looks like, well, I had to bend my line a little, so I am cheating just a little, but I feel pretty good about that answer. If I had had a straighter line, I'm positive, I assure you, it would have gone through without a little bendy there. But these are the 2 points that are most important. 0, 3 and 5, 5. Those are going to be really easy to graph on my WAMAP homework. Okay? So there's another way that we haven't even talked about. You might have heard about it before. It's called the slope-intercept form. The slope-intercept form, you've heard of the y equals mx plus b, maybe? So that's what we're going to do. We're going to take this equation, and we are going to solve it for y. But first, let's talk about what this is. Whoops. Whoa, never mind. There we go. So we want something in y equals mx plus b form. Mx plus b. First of all, the m is the famous m that represents slope. Slope is a measure of steepness. Slope measures the rise over the run of any line. If you wanted an equation for this, it would be the difference of y, y2 minus y1, over x2 minus x1. We're going to be doing something like that in a minute. Stay tuned. But mostly, it's rise over run. The b represents the y-intercept. The y-intercept is where the graph crosses the y-axis. In this particular case, I already know the y-intercept. The y-intercept is right here at 0, 3. In order to do this, we are going to take our equation, 2x minus 5y equals negative 15, and we are going to solve this for y. So, whoops, I keep doing that, sorry. The first thing I'm going to do is subtract 2x from both sides, minus 2x, minus 2x. Because I know I want it in y equals mx plus b form, I'm going to put my negative 2x first. So it's negative 2x minus 15. Negative 15 and negative 2x are not like terms, so I cannot put those together. I cannot combine them. Then, how is negative 5 attached to y? By multiplication. The opposite of multiplication is division. I'm going to divide each piece by negative 5. The negative makes it a little tricksy, so don't let it trick you. Here, a negative divided by a negative makes a positive, so we get 1y. Oh, look at this. Negative divided by a negative, positive 2 over 5x. Another negative divided by a negative, plus 3. So, in this particular case, the slope is 2 over 5, and the y-intercept is 3. We already talked about this y-intercept. On the y-axis, I go up positive 3, and there it is. Bingo. Let's talk about the slope. For a slope, if it is positive, I know that my line is going to go up to the right. A positive slope means it goes up from left to right. A negative slope means it goes down from left to right. Down from left to right. This slope is positive. So, from my y-intercept, this point right here, I am going to go up to, and I'm always going to run to the right. If the slope was negative, I'd go down, but this slope is positive. So I'm going to go up to 1, 2, and then I'm going to go to the right, 5. 1, 2, 3, 4, 5. How good do I feel about this answer now? Pretty amazing, because it was verified. I'm graphing my line using intercepts by plugging points in and by using the slope-intercept form, and it got me the same line every time. If I was just doing it by y equals mx plus b, I would have graphed the y-intercept and then did just exactly what I did, use the slope, go up to over 5 to get to my next point, and then I would connect those 2 points with a line. How about this one? Let's do another one, because it was so much fun. All right. First, let's use intercepts. Remember, The y-intercept occurs when I plug a 0 in for x. The x-intercept occurs when I plug a 0 in for y. So take a moment and pause this and see if you get the x and y intercepts. All right, so let's see. 3x minus y equals 2. Plug my 0 in. Negative y equals 2. Why did I do this one? Because sometimes people get a little fooled by just that negative. This is negative 1y. Whenever there isn't a number, it's always understood to be 1. So I'm going to divide both sides by negative 1. And that means that y is equal to 2 divided by negative 1, or negative 2. Negative 1, negative 2. Here's my y-intercept. Let's do the x-intercept. 3x minus y equals 2. Well, that's 0 right there. So now I get 3x minus 0 is just 3x. 3x equals 2. Divide both sides by 3. X is equal to 2/3. That's kind of tricky to graph, isn't it? Let's try it. 2/3 would be 2/3 of the way between 0 and 1. It'd be about here. Nah, I'm not loving this. Sometimes intercepts, when they give you fraction answers, kind of stink. I don't know. I'm not impressed. Not impressed with that. So let's go ahead and plug some points in and hope that we get some numbers that are not fractions. So remember, B is plugging points in. And I often will graph lines several different ways because I always like to check my work. I make a lot of mistakes, and so I always have ways to back up myself and check my work. I'm going to include 0, negative 2. And remember what I do. I take the coefficient of x and I put it in for y, so that would be 3. And then I take the coefficient of y and put it in for x. Whoops, wrong place. And see what I get. Oh. So let's see what happens. First, we're going to plug in the 3 in for y. So we get 3x minus y equals 2. That gives us 3x equals, I'm going to add 3 to both sides, 5. Ew, no way, I don't like that. 5/3, no thanks. That's 1 2/3. I don't want to have to graph that. But let's do this other one. 3x minus y equals 2. Put a 1 in for 3, and that gives me 3 minus y equals 2. Subtract 3 from both sides. Minus 3, minus 3. That gives me negative y equals negative 1. And this really is understood to be a negative 1y. So I'm going to divide both sides by negative 1. And a negative 1 divided by a negative 1 is positive 1. So the answer is 1, 1. Well, when I do that and put it here, does it look like all those points fall in a line? It actually does to me. The other point, remember, was 1 2/3, 3. So I'm going to go 1 2/3, 3, which would be about here. Do I feel good about those answers? Yeah, I do. I feel pretty darn good. So my graph, well, actually, let's not graph it yet. Let's do the third method, which is y equals mx plus b. All right, so I'm going to start with my original equation, which is 3x, that's too messy for you. You deserve better. 3x minus y equals 2. Okay, I'm going to put my line of equality here. I am going to subtract 3x from both sides. And if I do that, I get negative y equals negative 3x plus 2. Remember what that negative means. It means there's a 1 hiding. So I'm going to divide each piece by negative 1, negative 1, negative 1, negative 1. That means that I have y equals 3x minus 2. Here's where it gets a little confusing because the slope, remember, it's y equals mx plus b. So m is 3 and b is negative 2. But when I go to graph an m of 3, I would encourage you not to call it 3. I would call it 3 over 1. 3 over 1 and 3 are the same things. Remember, slope is always rise over run. And it's hard if you don't have anywhere to run. So you always want to put that in. And then my slope is negative 2. So remember, when I go to graph these kind, I start with my y-intercept of negative 2. And then I'm going to go up 3, which is going to be 1, 2, 3. And then I'm going to go over 1, over 1. Oh, look at that. It connected those two so beautifully. And I can do it again if I want to from this new point. I can go up 3, 1, 2, 3, and over 1, 1. And look what a beautiful line I have. I can even go down 3, 2, 3, and to the left 1. All of these points are in a beautiful line. Lines are beautiful. There's that and that. Oh, crap. Disregard that terrible thing. I can do better. Let's see if I can really. This tool is just very clunky on my Microsoft Surface. I am grateful for it, but there we go. It's a win. There is my nice, new, improved line. All right. The next problem is writing an equation of a line. Ooh, that can be confusing. It doesn't give me an equation. It just gives me 2 points. I would recommend that you run to the store right now, pause this video, and go buy some graph paper. Go to the store, get some graph paper. It's so helpful. All right? And why is it so helpful? Because I get to see what I am doing. You don't have to have graph paper to do this problem, but I think it helps. All right, let's graph these points. 1, 8, 2. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8, negative 2. So there's 8. And negative 2, negative 2. There's one of those points, the 8, negative 2. And then the other point is negative 4. 1, 2, 3, 4. There's negative 4 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. Negative 4. Go up. I think that's negative 4, 10. So what we actually want is the equation, and I'm going to try and graph this, of the line that goes through these 2 points. keeps shaking. It's like, there we go. Let's see. That looks pretty darn good, doesn't it? That does. I wonder if we have an accurate representation of the y-intercept. Remember, whenever you are graphing a line, you need two things. You need an M and you need a B, a y-intercept. I think it looks like the y-intercept is at 6. We'll see. We'll see if that's true. Let's talk about the slope. A few things about the slope. I can tell, because it goes down from left to right, I can tell the slope's negative. Definitely negative. And that's part of why I graph things, because so many people make all these tiny little algebra mistakes, and there's so many positive and negative signs. Oh my gosh, it can get really hard. So let's count. So to get from this point to the next point, I went down, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went down 12. And then how many did I go over? Let's see. 1, 2, 3, 4. And then 5, 6, 7, 8, 9, 10, 11, 12. Oh, I went down 12 and over 12. See, this is 12 spaces. This is 12 spaces. So my slope is actually -1. Or, in the terms I like, -1 over -1. So that means I'm going to go down 1 and over 1. Does it really work? Let's check. So I'm going to start at this point, -4, 10, and I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. I'm having a down 1 over 1 party, and I keep doing that. Each one of these points is on the line, woot woot, down 1 over 1, until I get to that point. And so it's perfect. So I know what the slope is. It's -1. And I know what the y-intercept is. It's 6. My final answer then is y equals mx plus b. Now let's suppose that you didn't have graph paper. I feel bad for you. I'm sorry. There is a way to do this though. So let's talk about it. We're going to solve for the slope using our formula, y2 minus y1 over x2 minus x1. I'm going to label these. It's totally arbitrary. I'm going to call this x1, y1, and I'm going to call this x2, y2. Now, because so many people get confused on the plus and minus signs, I always put my minus in first. And then I'm like, okay, y2 is 10. And what's y1? y1 is -2. Do you see why I did that? Oh my gosh. Minus and negatives, they mess so many people up. x2 is -4. x1 is 8. So remember, minus a negative makes a plus. So what I have in the numerator is 10 plus 2, or 12. In the denominator, -4 minus 8, -12. Then that means I go, oh yeah, my slope, it's -1. From my graph, I could tell it was -1. Now what I have to do is take either one of those points, sometimes I do both, and I'm going to use the point y equals mx plus b. I'm going to borrow an x and a y, plug in my m, and solve for b. Let's go ahead and do this using both equations because, let's face it, math is fun. So in the first one, I'm going to use 8, -2. So my y value is -2 equals my m value is -1. Y equals m. My x value is 8 plus b. Y equals mx plus b. If I solve this, I get -2 equals -8 plus b. I'm going to add 8 to both sides, and I get b is equal to 6. Oh, did you notice? I already said that, b equals 6. So my algebra way is confirming how I did it when I used graphing. Let's do the same thing with the other point, -4, 10. So the y is 10. 10 equals m is -1. The x is -4 plus b. So I get 10 equals 4 plus b. Subtract 4 from both sides, and guess what happens? 6 equals b. And you can say, oh, Debbie, I already knew that. Congratulations. So when it wants the equation of the line through points, I have a choice. I can graph it and hope that my y-intercept is very obvious and that my slope is also, but I can also use algebra first by finding my slope and then finding my y-intercept by using x, y, and the given m value to find your b. Isn't that fun? All right. Now it's everybody's favorite thing. It is a word problem. Yes, I know you like word problems. That is me slurping my water. All right, let's talk about this. A company has a manufacturing plant that's producing quality canisters. They find that in order to produce 290 canisters in a month, it'll cost $8,900. To produce 500 canisters in a month, it'll cost $13,100. Write an equation in slope-intercept form where x is the number of canisters and y is the monthly cost. All right, we are going to create 2 ordered pairs. The first ordered pair is based on this statement. To produce 290 canisters in a month, it will cost $8,900. Actually, I did that in blue, so I'm going to make this blue. So x is the number of canisters, 290 in this case. Y is how much it costs, $8,900. We've successfully created 1 ordered pair. So now let's do the next ordered pair. The next ordered pair says to produce 500 canisters in a month, it's going to cost $13,100. So my next ordered pair is 500 canisters, $13,100. I have 2 ordered pairs. What I've been asked to do is to create an equation in y equals mx plus b form. You might ask, what is step 1? Well, this actually becomes very similar to the problem that we did before. But the problem we did before could fit on our graph. I am not going to make a graph that goes up to 13,100. Ain't going to happen. So I'm going to use my formula. M equals y2 minus y1 over x2 minus x1. Let's call this guy x1 and y1. Whoops, except I wrote the wrong thing. x1, y1, let's call this guy x2, y2. By the way, if I switched those, it totally would still work. All right, so I've got 13,100 y2 minus y1 over x2 minus x1. Oh man. Let's see, this is 210. You know what? It's been a long day, so I'm just going to reach for the calculator. I'm not going to lie. 13,100 minus 8,900. 4,200. So I've got 4,200 divided by 210. Do you know the trick that if there's the same number of zeros, I can cross those out. The answer will be the same. 420 divided by 21, that's going to be 20 times. Okay, so I've got an m. It's 20. The next thing I'm going to do is use y equals mx plus b. If I've done this correctly, no matter which xy I use, I will get the same b. So, oops, let's do it. Why not? Why not indeed? So y, let's first use the blue. So y is 8,900. Y equals mx plus b. So remember, we just found our m, it's 20. So I'm going to put a 20 here. So I'm going to take 290 times 20 and get 5,800. So I got 8,900 equals 5,800 plus b. Subtract 5,800 from both sides. And b is equal to 3,100. You know, if I was a lazy mathematician, I would stop here. But I make a lot of mistakes, and I always like to check my work. So now I'm going to use the other ordered pair. Y, or 13,100, equals m, which is 20, x, which is 500, plus b. 13,100 equals 10,000 plus b. If I subtract 10,000 from both sides, guess what I get? Did you guess? You did already, didn't you? I got b is equal to 3,100. You know how good I feel about this answer? I feel good because these two match. I have an m of 20. I have a b of 3,100. So my final answer is y equals mx plus b. Sometimes we get an answer that is infinite or no solutions. Let's talk about this. This says to solve the system by graphing. We're being asked to graph two lines, okay? To solve a system, means that we are finding the point of intersection. That is solving a system of equations. So let's graph these two lines. In this first line, we'll graph it in red. We've got an m of 2, which I'm going to call 2 over 1, and a b, a y-intercept, of 1. Here's my y-intercept. I start with my y-intercept, and then this is my rise over my run. 1, 2, 1. 1, 2, 1. down 2 over 1, down 2 over 1. So there's that line right here. Okay. So then in my next problem, let's do it in blue. I've got negative 3x plus 6y equals negative 12. Ooh, that was terrible. I want to get y by itself, so I'm going to add 3x to both sides. And I end up with 6y equals 3x minus 12. Now I get to divide each piece by 6. My answer is y equals 1/2 x minus 2. All right, so that means my m is 1/2, that ought to be easy, and my b is negative 2. Don't forget the negative. Here's negative. So I'm going to go up 1 over 2. Rise 1, run 2. 1, 2. Up 1 over 2, up 1 over 2. The opposite of that would be down 1 and left 2. Oh, I'm so glad I did that because look, there's my point of intersection. And now I'm going to graph this other line right here. There it is. Did I get it? There we go. My solution is that point of intersection. What is that point of intersection? It's negative 2, negative 3. That is my answer. Let's talk about what happens when you have infinite or no solutions. Infinite solutions would occur if I graph a line, let's suppose it looked like this, and then my other equation ended up graphing a line right on top of the given line. Remember, a solution for a system of equations is what points do they have in common? Well, if the lines are on top of each other, they have an infinite number of points in common. That's why the answer is called infinite solutions. What happens when there's no solutions? Can you think of a time when you would have two lines and they would have no points in common? Yes, this happens when my lines are parallel. So if I have one line here and one line here, if they're parallel, what points do they have in common? None. So there's that answer. They don't have any points in common. Graphing lines can be fun, but it can be challenging. So stick with it. And if you have problems, please let me know.